Hello and welcome to Golden Geography. Today we're looking at glaciation. We are going to be focusing on the Glaciated Landscapes unit from OCR Geography A level. Here we have a copy of the specification. We're looking at key question 2, how are glacial landforms developed? We're specifically looking at point 2A, glacial landforms developed due to a variety of interconnected climatic and geomorphic processes. 2B is a case study which applies this information to, and we'll look at that in a separate PowerPoint. 2A, glacial landforms due to a variety of interconnected climatic and geomorphic processes. Let's start by thinking a little bit about some of those processes. Here we need to think about how energy and materials will influence some of those geomorphic processes, such as weathering. So weathering is the breaking down or the dissolving of rocks and minerals on the Earth's surface. Key phrase here is in situ, meaning that there's no movement as such. There are 3 key different types of weathering: chemical weathering, biological and physical weathering. And if we have a little look at the graph on the right-hand side, we can see that these vary according to annual rainfall amounts and average temperature. So if we think about our glacial environments where temperatures tend to be around 0, we are mainly looking at moderate chemical weathering, frost action, and some slight physical weathering involved. Stronger physical as we get into colder conditions, but we're mainly focusing on those physical, sometimes termed mechanical weathering processes. Of those, the 2 main ones are freeze thaw, as you can see here in the diagrams, and frost shattering. There's a very subtle difference between these 2. Freeze thaw is when water gets into cracks and freezes and thaws on a diurnal basis, daily basis, causing the rock and the cracks to be forced apart. Frost shattering is similar. The water gets into the pores within the rock, but the very rapid cooling of that water and freezing of that water causes the rock to shatter. So not just to split, but to absolutely shatter. So subtle differences between these 2 techniques, these 2 geomorphic processes, but they are both important in our glaciated environment. We need to think a little bit about mass movement too, and there are lots of different types. We have rockfalls, landslides, mudslides and slumping. When we look at our glaciated environment, we are definitely going to have a significant number of rockfalls. You might find some mudslides during periods of deglaciation, but these will depend on the amount of energy and the materials that are happening in that specific glaciated environment. So rockfalls particularly will have lots of kinetic energy involved in them and are often involved in the modification of landscapes as well as providing debris to the glacier. We need to think a little bit about glacial erosion too. There are lots of different types of erosion. Erosion is slightly different to weathering because it involves the movement of material that's being broken down. That process of breaking down or eroding the material is often involving wind or water. In our case, we're looking at ice as a solid version of water, or H2O. We have 4 different types: abrasion, attrition, hydraulic action and solution. In our glaciated environment, abrasion will play the biggest role. There will be some attrition, but very little or next to no hydraulic action or solution. However, there is an additional one called plucking that does play a key role in this environment. We also have a geomorphic process called novation. This is a little bit more complicated as it involves a combination of factors. This is looking at how snow can get compacted in a hollow within the landscape. As it gets compacted, it turns to firn and névé. So it loses a lot of the air mass that it has and becomes much more solid. Effectively, it's the process of diagenesis, where you find snow becomes ice. As it becomes ice, you then start to get the freeze-thaw cycle and frost shattering take place beneath that ice deposit. And as a result of that, you get solifluction, the movement of the ground beneath it, and eventually rotational slippage. This is a combination of processes that start the formation of a glacier, which you can find in corries. Energy is really key here. You are looking at making sure you have very cold conditions, so low levels of thermal energy for that snow to develop into ice, but also kinetic energy for that movement to take place. And we have transportation too, obviously involving kinetic energy and moving materials, debris from one place to another. That material can come from the back wall of the corrie, from the valley sides. Some of it might be just deposited by windblown activity. It can be moved by the glacier in different areas. So if it's moved on the top of the glacier, it's called supraglacial transport. If it falls within the crevasse, it may become englaciated and move within the middle of the transport, move in the middle of the glacier, or it may be finding its way to the bottom of the glacier or be plucked from the underlying geology and moved by subglacial processes. And if it's moved, then eventually it will be deposited. Deposition is where we have a decline in the amount of energy, and we will find that our glaciers, just like rivers, will deposit bigger materials first and then smaller materials later. It can lead to sorting, but it depends on the landforms that you're looking at. Also depends on the rate of deglaciation that the glacier is experiencing. Okay, 2.A, looking now at the distinctive landforms that are created as a result of erosion and some of those geomorphic processes we've just mentioned. So first of all, a corrie. Nervation plays a really key part in the formation of a corrie. Corrie are these big macro scale landforms that we find when an area experiences deglaciation. They are uncovered and they tend to be this kind of bowl shape or seat shape feature with very steep sides. We have a little description here that you can pause the video and read. It might be useful to apply this to either 8-mark questions or even essay questions where you may need to include the description of a corrie. Corries are really important as they are the start of your valley glaciers. Once you have a corrie, other landforms will develop from that, including arêtes. Arêtes are these really steep-sided, narrow ridges that can be found where you have 2 or more corries. They can be very distinctive. People love to walk on them. A really good example is Striding Edge that is found in the Lake District. It's a bit of a tourist hotspot. So again, feel free to pause the video, read the description that we have here, and see how you might apply that to an exam question. Similarly, if you have the formation of corries, you are likely to find that you will get a pyramidal peak. This is where you have 3 or more corries eroding backwards towards each other, and where they meet, they create this peak at the real height of the point at which they join. This takes a long time, and these areas are really exposed to weathering processes. A really good example is the Matterhorn. Again, feel free to pause the video, read the description, and apply it to exam questions. Here we have the formation of distinctive landforms, looking at what's happening beyond the corrie and that upper area. And often that involves the formation of U-shaped valleys. U-shaped valleys very often replace what was once a V-shaped valley, and it's where the river that flowed through that V-shaped valley has now been replaced by a glacier, and the glacier has widened and deepened that valley through the processes of abrasion that take place during that glacial period. Again, feel free to pause the video and have a look at the description. Here we're thinking a little bit about what's happening within those U-shaped valleys. We can find features like truncated spurs. These are where spurs that were formed by the meandering of a river have now been cut off and eroded by the glacier that replaced it, often having quite steep sides and creating quite distinctive areas that just have very sheer walls, often indicated by striations. Similarly, in some places where you find you might have had effectively tributaries, but glaciers that are in place of rivers that are joining a more central, bigger glacial valley, you may find something called a hanging valley. You can see in the picture here, it's often indicated now by a waterfall, and the key thing is you have a difference in the height of the valley. So the smaller glacier had less erosional power than the bigger one. So where they've joined, there is a difference in the height or the topography, hence why this waterfall can form. We also get mesoscale features like roche moutonees. These are found in those U-shaped valleys, are an indicator of the movement of the glacier. But the key thing here is the geology. You have to have variation in geology. You're looking at areas which have resistant geology in general, otherwise you would not have a glaciated valley, but with some areas of extremely resistant geology within that. And that very, very resistant geology is what has led to the formation of the roche moutonee. It's resisted the erosion of the glacier as it's moved over it. So you've got to have a combination of at least two different types of hard geology and subtle differences between those. Again, pause the video. Feel free to read through the description. You will find within your valley striations. These are small microscale landforms that show the direction of the movement of the glacier. You'll find them on truncated spurs and roche moutonees and on the bottom of the U-shaped valley as well. We will also find some distinctive depositional landforms within our glacial environment. Till is really important here. We have two key parts to this. We have something called lodgement till and ablation till. Lodgement till is when a glacier is growing and advancing and it's forcing the till it's carrying into the sides of the valley. Whereas ablation till is very much depositional and is deposited during periods of deglaciation and glacial retreat. Till is distinctive, it's very angular, it's unsorted, unstratified, because it's not really been eroded very much. It's been carried by the glacier, but not really experienced any attrition to make it rounder. So it's quite angular and therefore distinctive. We'll find moraine within or just beyond our valley glaciers. There's lots of different types of moraine. At the end of your glacier, near the snout, you should find terminal moraine, which is indicator of the fullest extent of the glacier, the furthest it once was. And you may also find recessional moraine, particularly during periods of deglaciation where the glacier has moved backwards and deposited material forming the moraine. Your terminal moraine will be much bigger than your recessional moraine. You may also find lateral and medial moraine actually on the glacier during periods of glaciation. Here you will find lateral moraines at the sides and medial moraine in the centre. Medial moraine is an indicator of where two or more glaciers have merged together. You may also find erratics. Erratics are really big They're called erratics because they don't make sense. You're looking at a boulder that has a very distinctive geology that's different to the geology of the surrounding area. So it's not been plucked or eroded from that area, it's been moved from somewhere else. Its geology, the source of the geology of the erratic, is different to the landscape in which it's found. Therefore, it has to have been moved and carried by a glacier. We also have drumlins. There are a couple of different ideas about how drumlins are formed. We're just going to stick with one that is thinking a little bit about the idea of having a core. Sometimes that core is an erratic over which material has been deposited around it. Drumlins can be the size of a car, but they can also be the size of a house. They can vary in size, but they can be up to 1 kilometre in length as well. They are indicators of the direction of flow of the glacier, and where you find multiple of them, they might show you the direction of movement of an ice sheet, in which case where you get lots of them, they're called a basket of eggs. Recently in Iceland, they've identified the formation of this happening as we've had rapid deglaciation due to climate change and increasing atmospheric temperatures. So scientists are quite interested in what's happening with these and how they indicate that kind of rapid deglaciation. And we get till sheets. You can see with this image here that we get large areas of till. Sometimes it's called ground moraine, but till sheets or ground moraine are literally where the glacier just deposits debris all over the area of which it's receding from. So as it ablates and moves back, it just deposits material. That's ground moraine or till sheets. So lots of landforms there, all of them tied into different geomorphic processes. Feel free to pause the video, go back, listen, or look at and read the descriptions of those landforms. Look out for those different geomorphic processes such as abrasion, plucking, freeze-thaw. Think about the amount of energy or the type of energy or the type of materials that are being used in those landforms. OCR very often has 8-mark questions based around these, but you could incorporate them into an essay question, a 16-mark essay question too. Finally, here we have a little image of a landscape, and key question 2b is asking us about how those landforms are interrelated. For example, if you did not have a corrie, and therefore the formation of a glacier, would you have a U-shaped valley? Obviously not. So they are interrelated, they do fit together. This ties into a case study, but that's on another video. So look out for case studies associated with the Nan Franklin Valley or Minnesota. And finally, have a little look at this tick list. I've just broken down the specification for you to look at. Tick off the areas you feel confident with in green. If you're not quite sure, maybe amber. If you really don't know, tick it up in red and make sure you check any red issues with your teachers.